Hello everyone and welcome back to the channel. In today's tutorial, we will build a LangGraph agent using tools from an MCP server. Specifically, we will deploy a Tavily MCP server for web search capabilities and connect it to our agent. Let's get right into it. So the first thing we need to do is install the Langchain-MCP-Adapters package. This package is responsible for the client part of the MCP protocol in LangChain. It allows us to connect to multiple MCP servers, load all their tools, and automatically convert them to LangChain tools that can immediately be used by LangGraph agents. Now that we have the package installed, let's see how we can build a web search agent using MCP. We will first create our LLM using Amazon Bedrock, then set up the Tavily MCP server and the MCP client to connect to it. We will then build our AI agent with LangGraph, and finally test it on a sample question. Let's get started. As usual, we load our Bedrock credentials from our secret YAML file, and we use the Chat Bedrock class to instantiate our LLM. Here we choose a Claude Sonnet 3.5 model. For more on using Amazon Bedrock models, you can check out our dedicated tutorial on the subject. You can also check out our LM Studio tutorials if you prefer using local LLMs. Let's now get into the main topic of today's video, launching the Tavily MCP server. For a detailed explanation of the MCP protocol, you can check out our recent video on the subject. As you can see here in the Tavily documentation, we have a dedicated page for the MCP server. Here we can go to the local installation section, and we find this very simple command using npx. All we need to do is copy this command and paste it in our terminal. We first make sure we have npm installed, so we can use npx commands. Perfect. Now we can execute the command, and you can see it immediately launches the Tavily MCP server with standard I/O transport. All you're gonna need is a Tavily API key that needs to be set as an environment variable. A very simple way to do it is to have a .environment file at the root of your project, containing all your environment variables. This is a public version of the file, so you can see what it looks like. If you don't have an API key, you can check out our previous Tavily tutorial on how to get one for free. Now that we have our server up and running, there's still one last problem. Tavily only supports standard I/O transport. Now standard I/O is only ideal for local communication. For real scalable use cases, we generally want remote communication with transports like SSE or streamable-HTTP. Supergateway is a tool that does exactly what we need. It can easily switch transport mechanisms on your MCP server, allowing remote access, even when your MCP server only supports standard I/O. As you can see, it can easily switch back and forth from standard I/O to SSE and vice versa, same with streamable-HTTP, and so on. Let's use this conversion, from standard I/O to streamable-HTTP, and here we generally prefer the stateless mode, which is lighter and safer for scalable applications. So this is the command that we need to run in our terminal. As you can see, it's also an npx command, which directly invokes the Supergateway package, so we don't have to install it beforehand. It has a standard I/O flag, in which we can put our original standard I/O server command. In our case, it's going to be the npx command we just saw for Tavily. It also has an output transport flag. Here we simply put our target transport mechanism, which is streamable-HTTP. Finally, we can use the port flag to set a port of our choice, for example 8000. Alright, now we can just copy this command, replace the values, and paste it in our terminal. You'll find the full working command here in the notebook. We place our original npx command here, and keep the other flags as they are. Okay, let's copy this command. Stop the original server, clear this terminal, and paste the new command. Click enter, and there you go. We have our Tavily MCP server up and running, listening on port 8000 with this endpoint URL. And that's it for the server setup, which was the most complicated part of this tutorial. Next, we move on to the MCP client setup. Here, we define this simple config dictionary with the endpoint URL of our server and streamable-HTTP as the transport mechanism. Next, we use this config to instantiate a multi-server MCP client object from the Langchain-MCP-Adapters package. We give a random name to our server, for example, Toolbox, and that's how we get our MCP client instance. With this dictionary structure, we can connect to multiple MCP servers at once by specifying a name and a config dictionary containing the URL and transport method. Let's now see how we can interact with our MCP server using this client. All we need here is the getTools method. This method does two important things. First, it displays all the tools available in the MCP server, with a very detailed AI-friendly description of each tool. Second, it returns them as LangChain structured tool objects, which can immediately be plugged to a LangGraph agent. As you can see, it already contains a complete description of each tool, along with a very detailed argument schema, describing every parameter of the API. Let's take a closer look at the argument schema for the Tavily Web Search tool, which is the first tool here. We can see it has a query parameter with its description, search depth with an enum type and its description, and other parameters like topic, days, time range, and so on and so forth. It also mentions that the only required parameter is the query. We now move on to the easiest part of this tutorial, building the LangGraph agent. Here we'll create a simple React agent using the pre-built Create React Agent method from LangGraph. For a more detailed explanation of what happens under the hood, you can check out our dedicated LangGraph agent tutorial. This method takes as input an LLM. Here we simply put our previously created Bedrock LLM and a list of LangChain tools. As we saw earlier, we immediately get the list of tools from the server in LangChain format using the getTools method. We feed this list of tools to the pre-built method, and there you go. We now have our LangGraph agent, equipped with all the tools from our MCP server. We can use this simple line of code to visualize its structure, and you can see it's a classic React agent with a start node, a conditional loop between the agent and tool nodes, and an end node. Finally, we write this simple function, which allows us to run our agent on a sample question and stream the internal steps in a structured way. Let's now test our LangGraph agent, using our runAgent function on this sample question. What is the A2A protocol in AI, and how does it work? As you probably know, the A2A protocol was first announced by Google in April 9, 2025. It's therefore something that our Bedrock LLM can't already know about, since we chose a Claude Sonnet 3.5 model from June 20, 2024. Let's now see if our LangGraph agent will correctly use the Tavily MCP server to answer this question. Okay, so we can see the first message is a human message, which corresponds to our initial query. We then have an AI message containing a tool call. Our agent calls the Tavily search endpoint, reformulates our question and puts it in query, and sets the search depth to advanced. Next, we have a tool message, which specifies the name of tool and the results. The results are organized in blocks with a title, a URL, and a content. Finally, we see an AI message again, this time containing the final answer of our agent. Using the search results from the tool, it provides us with a full description of the A2A protocol. It's a communication standard designed to enable AI agents to work together, regardless of their vendor or underlying model. The agent then goes into the specifics of the protocol, including standardized communication, the client-server model, the task structure, and so on and so forth. And that's it for today's tutorial. We've seen how to deploy the Tavily MCP server using NPX, how to convert it from std-io to streamable-HTTP using Supergateway, and finally, how to plug it to an AI agent using the Langchain-MCP-Adapters package. More tutorials about MCP and A2A are on the way, so keep an eye on the channel, and don't forget to like and subscribe if you appreciate the content. See you in the next one. Bye-bye.